Hi everyone, my name is Julianne Albion and today is June 20th, 2020 and we'll be doing Advanced Interactive Concept Module 4, which is making a fireproof balloon for Chemistry 1. So here are a few things that you're going to be needing. So for this experiment, we're going to need a lighter. So I have a barbecue lighter, just going to be easier. I'm kind of afraid of fire, so bear with me, just in case. Okay, so then we have a balloon, and for the sake of this experiment, I already blew it up, but you can get two kinds of balloons. So one that you're going to fill with air, and then one that you're going to fill up to like a little bit of the balloon. I didn't do a really big one because I don't really want to pop it that loud because my dog is here, so I don't know if that's going to cause an error in this experiment, but that might be an error. So there's just water at the bottom, and then after I put a little bit of water in it, I blew it up with air. So my hypothesis is that balloons and flames don't usually mix well with fire, but if you run the balloon usually under the water, if you run the flames under the water, it should prevent a fire. So we're hoping that I don't burn down the whole house right now. That's the goal, just to have them pop, because the air will make them pop. And then the one that has the water won't really pop. It'll just kind of like darken up on the bottom. So basically water is a good substance that would soak up the heat, and the thin latex balloon would allow the heat to pass through quickly and warm up the water, so it would just kind of heat up a little bit. So I'll let you know how that works up, because I do believe the bottom part would end up being black because I'm using a real barbecue lighter. So the fact that the water exchange is happening so often, that would keep the balloon from popping. So that's what's going on over here with the heat and the water. Until the heat of the flame is greater than the water's ability to conduct the heat away from the thin latex, then the balloon would pop in the air portion. So we're planning that this portion will pop, but once you heat it up over here, it will pop in the area over here. So the soot that would be on the bottom would actually turn out to be carbon. And the carbon was deposited on the balloon by the flame, and the balloon itself would remain undamaged, which is why it doesn't pop. So that's why this balloon with the water in it, you can see there's just a little bit. Not sure if that's also another source of error, the fact that I actually blew up the big air one. But this one's still going to pop in like 2 seconds, and then the only reason why this one should pop is because the air on this portion, I didn't really tie them too tight. I mean, they're tied and knotted on the top, but that's really it. So I wonder if there would be a different type of balloon, only because this experiment's pretty much over once they pop, so I'm just going to do my speculation right now. So I wonder if I did use a different kind of balloon in the experiment, if it would have different works. Like I know that they have like the not the latex ones, they have the foil balloon. So I wonder if that would be the same kind of thing, like if you filled up the same amount of water and then you put the water in and then you blow it up with the air. Will it still pop? Probably, because like the oxygen is still inside of it, but then again, foil is a different kind of material, because I do know that when you blow these kind of latex balloons up with helium, they don't last as long. They usually last like 6 to 8 hours, whereas those foil balloons will last a few days. Even when you have to add like the extra helium stuff in it, it doesn't usually last. So those foil ones last longer, which is probably why, because these are a thinner kind of material. Also, I wonder if the size matters. Maybe if it was a different kind of latex balloon, if that would pop quicker with the same kind of lighter. So I also wonder. I know in some video examples I saw, even if you had like a regular little kind of flame, any kind of flame really did the popping. And the example did show like a lighter, a barbecue lighter. So I do wonder if maybe there could be some kind of contamination, if something like that would cause the balloons not to pop. Or maybe if anything kind of got on it, like if maybe any kind of residue were on it. That would be really interesting. Maybe if you dipped in like flour or something, like something homemade from your kitchen, and that would make maybe that contaminated it. Or maybe I wonder what would happen if you actually kind of like rubbed some water around here on the outside of it, which is actually really cool. I wonder if you rub some water on the outside of the one, even though you put like the entire balloon filled with air. I wonder if that does anything to it. All right, so here we go. So first we're gonna take this one. So this one just has the air, and I'm very afraid of fire. So here we go. I don't really want to do this. So this one should pop right away. I'm just gonna back up just a little bit so you can see it. All right, there we go. Pop, just like I said. So now it smells a little bit just because it burned it. Okay, so like this one, I'm gonna take it, pop it over here because this one's gonna spill everywhere. Actually, I'm gonna move you over here just so it lands in my sink. Still right here. Okay, so what's gonna happen is in this portion right here, we light it up. So this part right here. Okay, so I'm just gonna show you the video. It actually just blackened. That's really cool. So that's all that bit of soot we were talking about on the bottom. And it's gonna happen again. So cover your ears. All right, turning the lighter on. So here we go. Just soot, and as soon as you hit this part right here, which is just the air part, it's gonna pop. Ready? 1, 2, 3. Woo! All right, there we go. That's how you make a fireproof balloon. Thank you, everyone.